Hi, and welcome to another edition of Ask the Meshperts. Today is a special edition of Ask the Cortexperts, where we'll be focusing on Cortex with Bryan Boreham, our special guest today. Ask the Meshperts is a series of Q&A sessions where we answer questions around service mesh, microservices, and Kubernetes. If you have any questions you'd like us to answer, topics you'd like us to focus on, or if you'd like to join us for an Ask the Meshperts, please reach out at hello@aspenmesh.io. Again, today we're talking with Bryan Boreham from Weaveworks and Neeraj Podar from Aspen Mesh to talk a bit more about Cortex, a horizontally scalable multi-tenant long-term storage for Prometheus. Bryan, do you want to give a quick introduction?
Yeah, hi. So my job title is Director of Engineering at Weaveworks, a company that's focused on really on making people successful with Kubernetes. We have some developer DevOps tools and recently very much into continuous delivery and what we call GitOps. So that's our kind of focus as a company. I have been working with open source, contributing to open source for 30 years now. So a lot of background there.
Great. Thanks, Bryan. Neeraj, you want to give a quick intro?
Sure. Hello, everyone. I'm Neeraj. I'm the platform lead at Aspen Mesh. Most of my time is designing, architecting, and building the platform and the enterprise service mesh that we offer. Great.
Well, thanks, guys. I'm going to launch into a couple of questions here, but feel free to take it anywhere you'd like today. So I think the big question is right now for me that there's a lot of adoption and momentum around Prometheus, especially since it's recently joined CNCF. Bryan, I wonder if you could give a quick overview of the Prometheus project and talk a little bit about where it's come from and where you think it's headed.
You mean Cortex there?
Oh, I'm sorry. Cortex. Yes, I do. Of course I mean Cortex.
Yeah, so I mean, Cortex really grew out of Prometheus. So Prometheus, as I guess most of the audience will know, is a time series database where time series is a varying set of numbers over time. Prometheus, as you say, very popular. The big thing is that it runs as one process. And what we wanted to do with Cortex was to make that horizontally scalable. And not only so to be able to run more than one process to scale out, but to break it down so you could scale the read path and the write path independently. So that's really what Cortex is. We take the Prometheus code. We take a lot of the Prometheus code. You know, the same code is used to get hold of the data samples in the first place. The Prometheus code is used to parse PromQL queries. Huge reuse, huge debt we owe to those guys. And then, so Cortex, as I say, splits it all up into multiple processes. It also replaces the back end. Prometheus' own time series database, TSDB component, is focused on storing those samples in files on the local disk. And with Cortex, we completely replace that code with a store using a NoSQL database. So we don't even write that bit ourselves. We use a store. You can use Google's Bigtable. We have a range of backend options, and we totally outsource the storage and durability problem to those pieces of technology. So that gives us even more scalability. You know, those are really scalable backend stores. And this idea of durability is a little bit non-obvious to begin with, but basically the whole of Cortex is built on the idea that things fail. So every piece of it, we try to run multiple instances that can fail over. When you get down to the disk, obviously what you need to do is store the data multiple times on disk. But not only that, if a disk fails, someone's going to replace that disk, and then the backend store has to actually copy over one of the existing copies onto the new disk. That's quite a lot of work. And so all of that we outsource to something like a DynamoDB or a Cassandra. That way we get long-term durability of data.
Yep, that makes a lot of sense. Great. Neeraj, I know that we've been using Cortex and prod for quite some time now. I'm curious if you could, following on to Bryan's explanation, how we're using Cortex to solve some of the challenges we were facing before that we weren't able to use Prometheus to solve.
Yeah, absolutely. Just to give a background on why even, what was the problem that we were trying to solve. Essentially, as part of our platform offering, we host Prometheus from our customers. So essentially that means we have to manage hundreds or even thousands of Prometheus instances. Now, initially when we started out, we said we are going to stamp them out for each tenant because Prometheus by default does not give you multi-tenancy and does not have those isolation principles built in. But very soon we realized that's not a very scalable solution for all the reasons that Bryan just mentioned. It tries to store data on disk. You have the problems with data migration. Try to upgrade 100 instances of a stateful application. That's not easy. You want to have multi-tenancy. You don't get that from Prometheus. And the most important thing was it was not a scale-out architecture. It's a scale-up architecture where both the read and the write, like Bryan said, scale up together. For us, scaling out, read independently of write was again very important. So all of these things combined, we're looking for a solution, and Cortex just fit the bill perfectly. Cortex has solved all these problems in a very nice microservice way. I think it's a microservices first distributed architecture. It has solved all of these issues. Essentially for me, Cortex is Prometheus++. I know it's a word being thrown out a lot. And if you look at the GitHub README for Prometheus, it says a multi-tenant, horizontally scalable Prometheus as a service, which is the perfect description. It's a lot of buzzwords, it looks like, but it is still the perfect description. So yeah, we went to Prometheus. I explored the initial design document, Project Frankenstein, which I found funny, the name. And even though I realized I was looking at a much older version of the document than the reality, the principles just made sense. And so far, we have been running it for 7 months, and we have been able to solve all the problems that we had. And now we think of Prometheus as mostly stateless applications. We can run any number of stateless Prometheuses, which are configured to send data remotely as remote storage to Cortex, and then we use DynamoDB to manage our real storage. And as Bryan said, most of the Cortex services are themselves stateless. We have best of both worlds.
Great. And it seems like this is a common problem right now with microservices, something that a lot of people need to solve. On that note, we've seen another technology that's coming out recently called Thanos. And I'm curious for your take, Bryan, on how Cortex compares to Thanos.
Yeah. So Thanos also seeks to solve the long-term durability problem with Prometheus. It comes at it from a different perspective. Thanos says you're running Prometheus already, so we're going to leave that alone. We're going to use your existing Prometheus for the kind of recent data, like the last day or so of data is still going to come from just the Prometheus instance that you were running anyway. And Thanos takes the older data and kind of ships it off to a store like S3, more the kind of block object storage, blob storage, I should say. I do not mean block storage. So yeah, they kind of started looking at a broadly similar perspective. Thanos never did multi-tenancy. They thinking about it now, but currently it is a single installation. It lets you create a global view of multiple Prometheus. So that's also a big similarity to Cortex. I mean, really, what I should say is the similarities are much bigger than the differences. They came at it from a different place. Thanos is again a microservice type architecture. There are multiple independent components. You can add things. The Thanos has some features that Cortex doesn't have, like a downsampling feature. So you can have your recent data sampled at like 10-second intervals, and then go down to 1-minute intervals for longer ago. So there's some feature differences. Cortex has a lot more caching on the read side, for instance, really focused on trying to cache partial results and cache data, so really get the queries going quickly. So yeah, kind of big picture, many similarities. They're different in the details. They came from a different place. And we know those guys. We meet at conferences, or we go for a coffee or whatever, and just kind of catch up on what's going on, see if there's areas where we can kind of collaborate together on bits of technology.
Absolutely, yeah. It's a small world. We tend to all know each other, don't we?
Yeah.
Great. Yeah, go ahead.
Shows the power of open source for me, where you can come at a stable API, well-used project and a well-loved project, and then build different solutions with different mileages, where I think both of them are useful given your use case. Like for us, multi-tenancy was really important when we were evaluating. We looked at Thanos. It was really early back then, but I could really see how someone will be using Thanos rather than Cortex, because that made more sense. They just wanted to make sure we can have a single pane of glass for multiple data sources.
Yeah, Cortex is coming up on 3 years since the inception. Thanos probably about half that time. So has had a bit more time to mature. But I have to say, Thanos is, if you measure by GitHub stars or something like that, a much more popular project. So I really admire them for that. They really did a great job of bringing people into the community.
Great. So Neeraj, as a user of Cortex, or Bryan as the core maintainer, I'd be really interested to hear in the year ahead, what are some of the technical challenges? What are some of the new features that you think it's important that are added to Cortex?
I'll let Bryan start.
Oh, okay. Well, actually, just to pick up on that last point, the making Cortex easier to kick the tires. The whole multi-process microservice architecture is great once you get going, once you want to scale the thing. But if you don't have Cortex running, how do you even start? That turns out to be too hard at the moment. So that's a project that's underway. Being able to run a real Cortex install, just really simply as a kind of kick the tires, let me see how this works activity. Some other things, there are bits of the architecture where data is in memory, and if a process crashes, then we might lose that data. Both at the sending side and at the receiving side, we do kind of double those processes up to lower the risk, but it's still a risk. So we talk about the write-ahead log idea, the idea that you put stuff on disk almost as soon as you get hold of it, and then kind of work backwards from what's on the disk, the write-ahead log. That is further along on the sending side than on the receiving side, but that's definitely something that we'd like to improve, that whole picture. More broadly, we're just always working on performance and really total cost of ownership. It's aimed at people with big installations. So even if you can kind of reduce the storage costs by 5%, say, then that shows up at the bill at the end of the month. So broad focus on those areas.
Great.
just to add a bit to what Bryan said, I would totally second the startup cost or the learning curve for Cortex is pretty high. I would, so for us, we quickly realized there were so many options that we had to create a Helm chart. Uh, Depending on whether you like or dislike Helm, it might be a good or a bad thing, but it did help us stamp out Cortex quickly in developer environments and then do upgrades. So that has really helped us, especially things around there are same set of options being passed in various places. So things like that can be easily templated out. So one of my suggestions has always been to other people who want to use Cortex, try to do something like this where it's more predictable. And hopefully we can also do that in the community in open so people can start consuming it if they like. I think reducing the set of options overall is critical. It makes it very, it's a balance because you want to have backwards compatibility and have feature flags and not leaving anyone behind. But it also adds too much complexity for the first time user to understand and triage all those options. On the ingester side, I have seen, just to add to what Bryan said, we can definitely make it more stateless, or if there is some state, throw it in a semi-persistent way somewhere. It will be interesting to see if there are performance enhancements, or rather just enhancements happening for isolation on the ingester path, where you can have more fairness among tenants. I think there was some work put out in the front end, on the query front end right now, recently, which really helped. We haven't tried and vetted it all the way, but I would love to do that. I think something similar or ingester will also work. And I think just the other pieces of Prometheus around alerting and rulers, those are again like the other Prometheus components, not meant for multi-tenancy, especially the ruler piece. So I think it will be interesting to see how Cortex plans on adding. Cortex plans on adding the scale-out architecture. So there is multi-tenancy in a very crude way, but you can't scale out some of these components.
Yeah, I missed that one. Yeah, the scaling out the ruler is just the bit that executes rules. If you have like an alert that you want to go off when something goes above a threshold, it needs to be continuously reevaluating that rule, and that is a component that never got the scale out touch. Yeah, so that is definitely on the roadmap. I want to make sure I mention, I'm one of the maintainers. There's a few of us. Tom Wilkie is one, was really the kind of inventor, came up with the original concept of Cortex. And others, Chris Gautam, you can go to the GitHub repo, github.com/Cortex project/Cortex. You can see the maintainers list there, but I want to stress there's a bunch of us working on it, and very much a shared endeavor.
Great. And, that leads me into a question about community growth in 2019. I know Cortex is a CNCF sandbox project now, seems to be gaining some pretty quick momentum. From a community and contributor perspective, where do you expect the project will go in 2019?
Yeah, well, I guess I preempted that question slightly, but this whole thing about getting started is a big issue. So there's kind of a really steep learning curve, and some people get over that and are running it. We've seen folks at EA, the games company, for instance, they got Cortex up and running, and they came along and they've made some PRs. They've made some great contributions. They're running it entirely internally. They don't offer Prometheus as a service. They run games, but they do have a lot of infrastructure to monitor. So those kinds of people, I think, are going to join in the community. Large technology companies, telcos, people like that. There are a lot of people interested. We, on the project side, we need to do a better job of helping people get started. We help we have a Slack channel. We really answering people's questions every day, but proactively writing down a cookbook of how to get started we're a little lax on that front. I should say we get some help from the CNCF. The CNCF has given us a tech author, some time from a tech author to help improve some of the docs, which will help. But community-wise, we run an open call about once every 3 weeks. Should be able to find the information in the repo. So people can come along and say hello, ask questions there, or we have a Slack. Is another good way to grab us, or maybe just open up an issue on GitHub. Yeah, we're hoping for growth. Let me actually mention a related project, which is called Loki, L-O-K-I. That is a log store built basically out of the core code of Cortex, and that was done by Tom Wilkie. He's working at Grafana Labs now, so it's in their area on GitHub. But that is kind of creating some interesting cross-fertilization, using the same principles of scale out and store management to do logs as well as metrics, time series.
Cool. Well, great, guys. I really appreciate the time today. I think this is a good place to end it, but thanks for all the insight on Cortex. And for everybody watching, thanks for tuning in. And again, feel free to reach out to us at hello@aspenmesh.io. Thanks.